Now we'll discuss a theorem in the definite integrals. And the theorem is known as the statement is as follows. Integral a to b f of x into dx is equals to. So in the integral, the lower limit is a while the upper limit is b. In between this lower limit and upper limit, we will introduce one more value that is known as c, so that this integral a to b can be separated as integral a to c f of x into dx. Now we will write it as c to b f of x into dx, such that we can write it as a less than c less than b. We can say that as c is the value which lies in between a and b, we can write it as a less than c less than b. Now in order to evaluate this, we'll assume that integral f of x into dx, we will assume it as how much? F of x. We'll assume it as f of x. Now let me apply the integral a to b on both sides. Integral a to b f of x into dx is equals to f of x, we can see that the lower limit is a while the upper limit is b. So this can be written as f of b minus f of a. That is a substitution of the upper limit and the substitution of the lower limit. Now, integral a to b f of x into dx is equals to, in between f of b and f of a, we are going to subtract one f of c and we will add one f of c. That is minus f of c plus f of c minus f of a. Now, this can be written as integral a to b f of x. We can write it as integral a to b f of b minus f of c. I will write it as integral, here the upper limit is b and the lower limit is c. This can be written as c to b f of x, that is a small f of x into dx, and here f of c minus f of a, we can write it as integral a to c f of x into dx, right? So this can be written as integral a to c, the second one I will write it as first, a to c f of x into dx plus integral c to b f of x into dx. This entire thing can be equal to integral a to b f of x into dx. So, whenever the lower limit is a and upper limit is b, we can introduce one intermediate value called as c, which lies in between a and b, such that integral a to b f of x dx is equals to integral a to c f of x dx plus integral c to b f of x dx.